The last page of 5.4, last two pages, is really kind of a rules recap of everything we've learned. So I'm going to use Excel to help me a lot through some of this. So let's start off with, suppose events E and F are independent, finds the probability of E and F. Okay, so we have two ways to find the probability of E and F. Right here, rule number 4, right? If they're independent, and general multiplication rule if they're not. All right, so since part A said they were independent, then all I'm going to have to do is multiply probability of E times the probability of F, which would be equal to 0.43 times 0.27, which is that. So let me write it out. Probability of E and F is equal to the probability of E times probability of F, which is equal to 0.43 times 0.27, which is equal to 0.1161. Done with that one. All right, suppose E and F are independent. Using the answer for part A, find the probability of E or F. Okay, so the probability of E or F is equal to the probability of E plus the probability of F minus the probability of E and F. Right? Okay, so we know the probability of E is 0.43 plus 0.27 minus 0.1161, which, let's go find that, equals 0.43 plus 0.27 minus that answer we found up there, 0.5839. Done. Next, suppose the probability of E or F is equal to 0.55 instead. Find the probability of E and F. Okay, so now we're going to use a different rule. Same one we just did, but they're going to give us different information. So it's this rule, but they're telling us that this is 0.55. And they want us to find the probability of E and F, which is, I'm going to call it X. Cool? Okay, so let's think. We need to know 0.55 equals 0.70 minus X, right? And then using some algebra, you know that you can add the X to the other side and bring the 0.55 over, which makes it 0.25, right? No, 15. Right there. That's the answer. I'm doing it in my head. Of course, you could use Excel, but right. 4, 3, and 2, 7 makes 70. Subtract away the 55, and you've got 15, and away you go. There's your answer for that one. Next, what about the probability of E or F if they're mutually exclusive? Well, if they're mutually exclusive, that means that there's no overlap. They're disjoint. So then the probability of E or F is equal to the probability of E plus the probability of F, which is 0.43 plus 0.27, which makes 0.70. Done. What about the probability of E and F if they're mutually exclusive? Well, the whole point of that is that there's no overlap. If there's no overlap, then the probability of the overlap is 0. Done. That's why we were just able to add these two up, because of this one. So in a way, D and E are kind of out of order. All right, what about the probability of E complement? That would be equal to 1 minus the probability of E, which is 1 minus 0.43, which is 0.57. Oopsie. Done with that one. All right. Suppose the probability of E and F is 0.21. What's the probability of F given E? All right, that's going to take our multiplication rules. Hold on one sec. All right, this is the general multiplication rule. So the probability of E and F is given to us as 0.21. We got to divide it by the probability of E, which is 0.43. And then we just go find that, and we'll have it. Equals 0.21 divided by 0.43, 0.48837. That's the answer. All right, and we just have to finish the next one. I'll have to finish it next time, and then we'll be all done with this section.